Hello friends, so today in this video we will be discussing the second problem from the latest Codeforces round 711, problem named box fitting. So I'll tell you in simple terms. It states that you are given a box of width W and then you are also given some rectangles who has a height equal to 1 and a width equal to some integer which is actually a power of 2. So as you can see in this example also, you are given some box which is open at the top, but you are given some width, let's assume 16 in this problem, and then you are given different boxes as you can see whose width is given to you, which are a power of 2, and also the height of all of these blocks are equal to 1. Now you have to find out the optimal height of this outer box you have to gain, or you have to make, such that you can easily fit all the blocks optimized in this whole box. So as you can see in this example, the maximum height or the optimal height which you needed will be 2, such that all of these blocks can be fitted in this box of width equal to 16. So that's the whole problem. Now I have used some of the code from the tutorial of this video to even make it more clear, because that code is very concise, but I'll tell you how to approach such type of problem. So as you can see in this problem, first I thought that it might be some deep problem to fit all of these blocks, but you can also do this in a greedily manner. So let's assume that the block, the width of this is 16. Now I have two blocks of 8 length, so I can put one block like this and one block like this. Now I have again, I have one more block of 4, 2 and 1, so I can put a 4 block, 2 block and 1 block. So this is 8, this is 8. So as you can see, now the height again is equal to 2 only. So it means that this is also optimal way, and it is shown in this problem, it is an optimal way also. So it means that you can easily fill this in a greedily manner also. So now what you can easily do in this problem is, at every level you can take out the maximum block you can fit at the space which is left to you. Which I mean by this is, let's assume that I have some blocks here. This is length is equal to 16. I have one block which is 8, so I can put a block which is 8. Now I have how much space is left at this particular level, so you can assume that this is some level. Okay, now if you know that, if you have somehow sorted all the blocks, you can easily find out which block is left to you, which block is left with you. Now if you can see that I have one more block of, if I used one block of 8 here, how much space is left at this level? If I have some space left is 8, then I can again fit this here only. Okay, but let's assume that I have this space left is equal to 8 and I don't have any block of size 8. Let's assume that I have the blocks left is of size 15. Also it is given that the maximum block length, it should be not greater than the block, the box size. It should not happen that a block can occur in which a block size is equal to greater than the width of this box. It doesn't happen. So as you can see, this is 8, so this is a maximum block, because I have the width equal to, let's assume 16 only for this problem. Now if I have my width equal to 16, I will have for the first level a width of 16 which is empty. Okay, so I will find out a block which can easily fit here. So let's assume that I find out a block which is equal to 2 to the power of 16 only. If I find out a block 16 only, then I can easily fit that block again. If I find out a block of 8, I can fit out a block of 8 here, and some space is left. Now if I have some block of, let's assume length 4, it is remaining, so I can put one block 4 here. Now I have again one block of 4 left. So how much space I have left here? I have some space left which is of 4 again. Now I have a block of 4 which is left again. I can put it again here. Now how much space is left? 0 space is left. So if no space is left, I will go to the next level. And now I have again how much space left? Equal to the width. Now I again have to somehow greedily fill all these blocks here. So it's just that we start from the bottom layer and we just pick out the maximum block I can fit in the remaining space which is left at that level. So at every level I have a empty slab, like in assume, which is of length width. Now I want to fill it with the maximum block as possible. If I can fill it with the maximum block possible, I will find out that okay, now this much amount of space is left. Can I fill this again with some maximum block possible? If I can fill that, then it's obviously okay. Else if I cannot fill this, I have to move to the next level and try to fill that now. Which I mean by this is, let's assume that I have some width which is equal to 10. Now if it is equal to 10, now I have some block which is equal to like 8. So I can fit one block of 8 here. And how much space which is left, which is 2. Now I will find out that whether I have a block of length 2 at this point. Whether I have. If I do not have, then like I cannot fill this space because I want a block which is of 2 or less. Okay, then only I can fill this block. If I cannot fill this block, I will eventually go to the next level only. If I go to the next level, I again have a free space of length of equal to width, which is 10. Now I will find out what is the maximum block I can fit. Let's assume that I have one more block of length 8. So I will put out a block of 8 here again. And then I'll again check that whether I have some block of size 2 left, which I can fill at this position. I do not have. So I will not fill at this position. I'll go to the next level. I hope you understand the logic part now. So what you can do here is, like, I just have to find out that what are the blocks which are left to me and whether I can place a block at this given spot. So I just have to search among all the blocks which are left to me whether I can find out a block of length of some particular length. Now it means that I have to use a data structure in which I can also delete some blocks because I'm using it, and then among all the blocks I have left, I have to find out a particular block. Like I have to find out all the blocks which are less than or equal to this length, which means that if I have some space left which is equal to 4, so I can only place a block in this 4 position which are of length 4 or less than 4, like a block of 1 size, 2 size, 4 size, and so on. I cannot place a block of size 4 at this point, or like 8 at this point, because I have space left equal to 4 only. So I have to also somehow do a binary search or like a search operation which can easily give you the information to find out what are the blocks remaining in this whole set which I have, such that the length of that block should be less than equal to the left space I have. And then that can be done using multiset, because you can do a binary search on multiset also, and you can also delete out and insert out the element easily in binary search in log time. So that's the whole logic. You can use the data structure binary like multiset for this purpose. So I will show you how the code works and how you can write down the code and so this is the proper explanation of this problem. I'll show the code part now. So what you can do, you will take the input of n and w, which is the number of blocks you have and the width of the cup or the box you have. Now you will make a multiset and you will insert all the elements in the multiset, which means that now I've inserted all the blocks in the multiset. Now initially my height is equal to 1 because I have to put some block now in the box. So if I will put out any block, then eventually I need a height of 1 because every block has a height 1. And what is the left? What is left width I have? Because I haven't put it any block, the width I have is w. W means the whole width is empty. Now I will iterate over the whole multiset such that I will do this while loop till there is some element in the multiset, because we have to use all the elements. Now I will find out or do an upper bound, which is like just doing a binary search and finding out the element whose length is less than or equal to left amount, like whether there are some elements. So if I do a upper bound, it will give me an element which is greater than or equal to, so let's assume that I want to find out 5. So it will give me the first index at which is greater than 5. Okay, so if I have some elements which is greater than 5, I will the multiset upper bound will give me the index which is greater than that. I hope you understand the point. And if there is no space left, let's assume that my binary search or the multiset has only 8. Okay, so as you can see, if I search for 4 in this multiset, that whether I have some because my space left is 4, I will search in this multiset whether there is some element less than or equal to 4 now. So I will search that. So it will give me the first index, because it will give me an index of the element which is greater than the element I'm searching for. So the first element greater than 4 is equal to this element. So it will give me this position. So if it will point me to the first index, it will eventually tell me that there is no element I can put it, because it is pointing to the first element. The first element means that there is no element behind it. And if there is no element behind it, I cannot put an element which can fit in the given space. So you cannot do this, and you just eventually move to the next level, which is the upper height. So that's what we are doing here. If my iterator value which I got, the iterator means that the position at which I have to find out that whether some left element, the left space I have, whether there is some element which can fit in that position. If there is some element which is there, or like if there is no element which can fit, then obviously, which I've told you, it will point to the first element. So if my iterator position is equal to the first position, which is ms.begin, it is the multiset position of the begin, then it means that I do not have any element which I can put there. So it means that I have to go to the next level. If I go to the next level, my left, I will eventually create a new slab, and new slab means now my left element, the left space I have, is again converted to W, which means that now I have a new fresh slab, and the space I have to fill in this slab is again W, and the height will increase by 1. Else, if there is some element left, which I have told you, so if it is not pointing to the first element, it is pointing to the let's say this element, then obviously it will give me the element which is greater than the element which I'm finding out. So I have to go to one step back, because that element will fit in the position I want. So I have to go to one step back, because upper one will give you the first value which is greater than the value which I'm searching for. So if you subtracted 1 from it, you will eventually boil down to the maximum element you can fit in that position. Now this is the iterator value. So this is like a pointer. So you have to convert it to the value itself. So you can just put a star in front of that pointer value, and it will dereference it to the value itself. Now if I've used that value, what is the space left at that particular slab? If I've used the particular value, then the space left is left minus that value is subtracted out. And we also have to delete out that particular element from the multiset also. So this is because we have subtracted -1, because we have subtracted out that particular element, we have to also erase out that particular element from the multiset. And in the end, the final height which we have found out by doing this whole placing out all the elements will give me the answer. So I hope you understand the logic and the code for this problem. The code link will be in the description. So if you have any doubts, you can mention it out. As soon as until then, keep coding and bye.